Hi, my name is Amanda Donaldson, and I am currently a PhD student within the Earth and Planetary Science Department at the University of California, Santa Cruz. My previous degrees are in a Bachelor's of Science in Forestry from the Humboldt State University. I'm an ecohydrologist, which means that I think about how water moves and is stored within the Earth's near surface, as shown in this schematic. Understanding water movement and storage has important implications for forest health, streamflow water quality, and freshwater availability. However, it remains difficult to identify and predict the dominant drivers of water storage because it is influenced by so many complex interactions. Aspect, or the direction a hillslope faces, provides a natural experiment to investigate how climate and vegetation interact to influence water storage and movement. Here, I have shown a series of hill slopes where the equator-facing slope, or south-facing in the northern hemisphere, receives more direct sunlight, has higher air temperature, and is dominated by grasses, compared to the pole-facing slope, which receives less direct sunlight, has lower air temperatures, and is dominated by oak trees. Here, I use this natural experiment to ask two questions. How does the interplay between climate and vegetation influence evapotranspiration, which is just the combination of evaporation and plant water use? And how does evapotranspiration mediate subsurface water storage? To address these questions, I've combined field-based methods with remote sensing techniques within a catchment in Central Coast, California. On the left, I have shown its location with a star and the natural distribution of the dominant oak species within the site. On the right, I have outlined the catchment with the equator-facing slope and the pole-facing slope delineated. Within this field site, I have quantified grass water use, dug soil pits to measure soil moisture, installed sap flow sensors to measure oak water use, and combined these techniques with remote sensing to estimate evapotranspiration on a larger scale. My findings suggest that despite lower air temperature, the pole-facing slope has more evaporation because the oak trees are using significantly more water than the grasses. Furthermore, remote sensing analyses suggest that because of this large magnitude of oak water uptake deep within the subsurface, the pole-facing slopes are actually drier than the equator-facing slopes, which is contrary to previous studies that have not fully considered the role of vegetation type in regulating water storage. Future work at my field site will quantify the effect that these differences in water storage have on vegetation health and groundwater recharge. Thank you for your support in making this research possible.